So let us have some interactive problem solving sessions by students who have taken this course. So you will see some illustrations and examples into problem solving which is useful to understand and digest the concepts learnt during the lectures.
So hello everyone, I am Priya Jain Adkarni, a PhD student at IIC. Today we will solve a problem which came in the exam 1 of the MMT SP course in 2015. So basically we have a structure here which is basically a 3-channel synthesis bank with 3 filters. Which is given by F0, F1 and F2. So there is an equivalent structure of it given using a DFT matrix R0 of Z, Z cube, R1 of Z cube and R2 of Z cube, and in the question it has been meant R0 of Z is been given as 1 plus Z inverse, R1 of Z has been given as 1 minus Z power minus 2, R2 of Z is 2 plus Z inverse, and what we need to do is find the expressions for the 3 synthesis filters, which is F0 of Z, F1 of Z and F2 of Z. So let us first understand the question. So this is given to us, and on the other end the same thing can be represented as a synthesis bank with 3 filters F0, F1 and F2, and we need to get the representation of F0, F1 and F2. So let us solve it. So from this particular figure which has this DFT matrix, W basically is the DFT matrix here. We obtain y of z is equal to z power minus 2, r0 of z power 3, y0 tilde of z plus z inverse r1 of z cube, y1 tilde of z plus r2 z cube, y2 tilde of z. So this is basically obtained by considering these signals here and then multiplying them by the respective filters impulse response and then considering these delays. So now we need to find out F0, F1 and F2. So we can see that, so let us first write down what F0, F1 and F2 is. Now suppose y1 of n equals to y2 of n equals to 0 for all n, that is y1 of z equals to y2 of z is equal to 0. Then the system reduces to just y0 of n, F0 of z and y of n. So therefore we have F0 of z in this case can be written as y of z by y0 of z given y1 of z is equal to y2 of z is equal to 0. So given that y1 and y2 are 0, we can write F0 in this format. So let us mark this as let us mark this equation as number 1 and this is number 2. So on similar terms, we write F1 of z is equal to y of z by y1 of z when y2 of z equals to y0 of z equals to 0. and f2 of z equals to y of z by y2 of z, given y0 of z equals to y1 of z equals to 0. So, let us label this 3 and 4. Okay. So, now going back from this particular part, let us obtain the equation. Yeah. So, from the DFT circuit, we have y0 tilde of z, y1 tilde of z and y2 tilde of z, which is basically the output from the DFT block, is equal to 1 1 1 1 omega omega square 1 omega square omega power 4, and the input y0 of z, y1 of z, y2 of z. So, basically this is 3-point DFT. So, let us label this as phi. One more thing to mention is that omega here is e power minus j 2 pi by 3. So, this basically implies omega cube equals to 1 and omega 4 is nothing but omega. So, from all these equations, let us compute f0 of z, f1 of z and f2 of z. So, first let us compute f0 of z. So, we set y1 of z equals to y2 of z to be equal to 0 in equation 5. So, this basically gives us y0 tilde of z equals to y1 tilde of z equals to y2 tilde of z is equal to 1. So, further using the equations 1 and 2, we get f0 of z to be z power minus 2 r0 of z cube plus z inverse r1 of z cube plus r square r2 of z cube. So, this is by replacing all these parameters into equation 1. So, we know the values of r0 of z, r1 of z and r2 of z. Let us substitute that. So, by substituting that we get z power minus 2 1 plus z power minus 3 plus z inverse into 1 minus z power minus 6 plus 2 plus 3 z inverse. So, on simplification we get this to be 2 plus z inverse plus z power minus 2 plus 3 z power minus 3 plus z power minus 5 minus z power minus 7. So, similarly let us compute f1 of z. So, again here we set y0 of z and y2 of z to be equal to 0 and we obtain. So, basically from equation 5 y0 tilde of z is 1, y1 tilde of z is omega, y2 tilde of z is omega square. So, again using 1 and 3 we get f1 of z is equal to z power minus 2 r naught of z cube plus z inverse r1 of z cube into omega plus r2 of z cube into omega square. So, substituting again we get z power minus 2 1 plus z power minus 3 plus z inverse omega 1 minus z power minus 6 plus omega square 2 plus 3 z power minus 3, and simplifying that we get 2 omega square plus omega z power minus 1 plus z power minus 2 plus 3 omega square z power minus 3 plus z power minus 5 minus omega z power minus 7. So, similarly we can do it for f2 of z, where we put y naught of z to be equal to 0 and y2 of z to be equal to 0. So, again from equation 5 we get y naught tilde of z to be equal to 1, y1 tilde of z to be equal to omega square, y2 tilde of z is equal to omega, and using 1 and 4 we obtain f2 of z is z power minus 2 r naught of z cube plus z inverse omega square r1 of z cube plus omega r2 of z cube. So, again substituting it back, so on simplification we get 2 omega plus omega square z power minus 1 plus z power minus 2 plus 3 omega z power minus 3 plus z power minus 5 minus omega square z power minus 7. So, one observation is that f1 of z is equal to omega square f naught of omega z, and f2 of z is equal to omega f naught of omega square of z. So, therefore, by using all this we have obtained f naught, f1 and f2. Yeah, thank you.